next week. Next week is y'all's break week. And let me know also if you have not received because by now you should have also received your career coaching schedules as well. So let me know. Slide in my inbox. Just email me if you haven't, and I'll make sure you got everything you need because that'll start up within the next like 2 or 3 weeks. Those are weekly as well. So any questions? Okay. All right, y'all. So the objectives of this week, we actually have more than one, like always. The objectives. Oh, let me record. Hold on. Okay. The objectives of this week are to manipulate string functions, joins, subqueries, and case statements. Manipulate string functions, joins, subqueries, and case statements. Those are all of our objectives for this session. This is where we get into more or less the more advanced parts of SQL. From our session 1, we focused on retrieving the data, making sure everything is structured correctly to get our data. We focused on making sure that like select from where, and we got into all of those logical operators where this condition is met and that condition is met, which I'm still going to have that on the screen today because you're going to have to reference that as we go forward. But from our session 1 and 2, they were focused on ensuring like that strong foundational understanding. These last 2 sessions are going to get into more or less more advanced parts of SQL, but they still very much so build upon what we already know. Just because we going into like other things does not negate what y'all already know, because you can just add it on there, like layer it basically. So first off, let's get into string functions. So what are string functions? You know how we are always in the database, and I'm like, okay, when I say put the single quotes around it, and I'm like, make it a string, make it a string, make it a string. A string of data is essentially what the value of that data is. What is that actual data that is within that column? That is the string. Think of it like when I don't even have a necklace on, but think about it like when you have a necklace and you have a Pandora bracelet, you have like the little charms on the Pandora bracelet. Those charms are the actual strings. It's the actual data itself. Those are strings, which is why when you are in a database and you have to put your condition and you say where this column equals this, and you put those strings around it, you're saying where this column equals this value. That's your string. Now, what are string functions? So string functions within SQL allow you to essentially extract the data that you need from a column, formalize the data to appear in the ideal way, and ensure that there's a high level of consistency. For example, if you are within a situation to where you only need certain values from this string. I don't need the full column. I need to create a column with certain extracts from the data. That is where you will utilize a string. They help you to manipulate that existing data to get out whatever you need. And that portion of your analysis is super useful for like data cleansing, creating new data sets or new formats of data. It's extremely useful for like that type of work. Another way that it becomes relevant for the work that you all do, let's say that you are in a position to where you have data and your data source is being extracted from a website. Y'all go to websites every day and it says, hey, What's your first and last name? How did you hear about us? All this stuff. You key in your data. That data that you're keying in is going to a database somewhere. However, due to the data being attributed to a user entry, it's clearly not going to be consistent, because the way that I enter data might not be the way that Natalie enter data, or Alexis or Valencia, anybody come behind. I might have uppercase, lowercase, I might have spaces. The next user might not. So therefore, the analytic professional has to make that data consistent. They do that by incorporating like what we call string functions. I'm manipulating that data to either meet a certain format or clear a certain way or look a certain way, in whatever way that I can use it. That is all a string function is. Now, do we have any questions before we go? Okay. Now, for our session today, we are going to focus on concat, upper, and lower. Those are just a few examples of string functions, because I feel like it gives you exposure to the concept and it allows you to apply it within a database. Now, y'all probably are familiar with concat, especially if you are heavy within Excel. And it was part of the reason why I incorporated it in here as well. Concat essentially takes one column and concatenates it, because it's short for concatenate. Takes one column and concatenates it to the other column and creates a whole new column. It does the same thing. I think the formula is almost the exact same within Excel. When you take one column, merge it to the other one. Here we have our select. Everything we do goes back to that select statement. Select. We have our function here. Concat is the function. We open up our parentheses. We name the column, comma. Here I'm putting the empty strings, because if I don't put this empty string, it's going to literally take these columns and mush them right on together. So I got my column here, an empty string here, this column here, close it up. Then I get into as. That's the alias. We'll talk about that even in our other, today, actually in our other modules with our joiners. This is the alias. I'm telling you to take this column, as full name. This column and this column, and name it full name. Call it full name from the employees table. This is what that concat function does. Take this column and merge it with this column. Now let's take it back to a example that is also probably will bring it back home to a lot of y'all. Some of y'all are in healthcare, some of y'all are in behavioral health, some of y'all are in industries where you have ID numbers. All day long, you have patient ID numbers, you have member ID numbers. If you're in like claims, y'all deal with that all day long, because that was my bread and butter too. Believe it or not, a lot of those ID numbers and a lot of those claim numbers, a lot of those patient numbers are attributed to simple concat. They could be concat, or it could be like a unique row. And what I mean by that is I can concat, I can't talk, y'all. One column and merge them together. And these two columns create this unique ID for this patient. People do it in healthcare literally all the time. So that's one way that concat is used. Do we have any questions? Okay. Now, was everybody able to get into your database? Okay. Okay, I see y'all in the chat. Okay. So let me go within our database. And for this one, let's actually go within our data analytics simplified database. I'm gonna move that one because that's the answer. And I ain't trying to. Okay. Golly. Hold on, let me move this because it's telling y'all the answer. Hold on. Okay. Now, okay. Now remember our database. This is the server. This is the brain. This is where everything functions. Oh no, we need that. No, you don't. No, you don't. This is the brain. It keeps everything organized. Your server down, you can't work. Like I said, the companies and things, they solely depend on them having constant access to their data. I think, like I told y'all last time, that we have to do an analysis when our server is down. They lose like $50,000 every 30 minutes. It's crazy. It's a lot amount of money. So your server's down, then they don't have access to the data. Okay. This is your database. We got our server, we got our database. Think of it like an umbrella. Now, these little blocks here, these are your databases. And the way that I teach y'all, even throughout our sessions, like today, we're going to be in multiple databases because it is not uncommon for your organization to have 40 databases, 30 databases. And it's your job to like go through, extract the data, look at the data, based on multiple databases. So today y'all gonna be going back and forth, back and forth. And that essentially mimics how real life works, basically. So these are your databases. Now, for starting out, let's get into our data analytics simplified database. We're gonna open it. Oh, that's the views. I'm like, baby, what is it? Okay, that's the views. Okay, so we're gonna get into our database. We're gonna open up our tables. This expands your tables. These are your tables. Now, also important, like I was stressing from session one, those data relationships, data dependencies. How is this how are these tables related to the next? So you as a data analyst, just open up your data, look at your columns. Open up your data, look at your columns. This skill is data investigation, and it will come in handy today for sure because we have to join tables, but throughout your entire career, because not only do you use it in SQL, you use it in essentially all analytic tools. Power BI, Excel, if you're doing pivot tables, you literally need to know or need to have some sort of post on how your data is related. So just do your data investigation. Just make it like second nature. Do your data investigation. Now, the first thing that I'm going to do, and I'm actually going to share the script, share the code on the screen, because the first use case that I'm going to give you all, was everybody able to access the data analytics simplified database? Okay. Okay. Now,
my internet is acting wonky, so it keeps kicking me out, but I'm here.
Okay. Now, the first use case that I'm going to give you is I want you to concatenate the first name, last name, and enrollment year. Concatenate the first name, last name, and enrollment year. I am going to post it in the chat. Call the new column student information. And I'm going to leave it up so you can have a point of reference to look at when you do it. So your first line of business, do some data investigation. Which tables houses this data? Which tables houses this data? Then right click, select your top 1,000 rows and start building your query. Which tables houses this data? That's your first thing. Okay. And I'm doing it with y'all. Okay. All right. And if you want to talk through it, just talk through it. Or if you feel like you got something, we can talk through that too. All right. Anybody want to share their code? Or y'all need a few minutes?
Can I have a few more minutes?
Mm-hmm.
Okay, I think I'm ready to share.
Okay. I'm going to stop so you can share.
Let us pray.
Girl, please.
Okay, so.
Put you on
no, I'm talking about my internet because it's.
Oh,
crazy.
Okay.
Okay, so.
Okay.
From what you gave us, first name, last name, enrollment year, from the investigation, the only column I saw that had all three was the students table.
Yeah.
So that's what I selected. I did the select top 1,000, deleted that out of there. Came in, put select CONCAT first name, did the space or the single quotes, last name, enrollment year. I think you said this was called alias.
Yep.
Student information from the data analytics simplified table. And I believe this is where my information is housed.
Absolutely. So let's talk through it. That's 100% correct. 1,000. You ain't do nothing wrong. 100% correct. I'm about to explain to them because they might be questioning why you got two outputs. That's all. but your code is 100% correct. So here she has, notice on line 1 through 6, she has her simple select statement all day long. Then on line 7 and 8, she came down with another select statement where she included her concat function. So the way that the system reads it is, if you have two different sections that are full lines of code, that's two different lines of code. She has in line 1 through 6 selecting from, in line 7 and 8 selecting from. She got two different lines of code in there. That's why she has two different outputs. When you have multiple blocks of code in your screen and you don't like comment them out, it'll just give it all to you. It doesn't mean it's right or wrong, but I do it actually sometimes in the event. Let's say that I'm doing data investigation and I want to see two outputs at the same time. I do it all the time. I literally do it all the time. Now, do not confuse that with having two selects in like one script, because it's not gonna work. But the way she has it is nothing is wrong with it. In the event that you need to see two separate outputs, that is essentially how she formatted that, and that's what came back. But like I said, don't confuse that with having select and then a couple of columns and then saying select again, because that's not gonna work. But if you got two different blocks like that, you're good. It's just gonna return exactly what you asked for. In the first line 1 through 6, that's a straight up select statement. In line 7 and 8, you see her concat. But yeah, that's good. Does anybody have any questions, or anybody have any questions?
I'm like a little confused.
Okay, let's talk about it.
So the part, just kidding. It was the part where it's like the quotes in between. I don't understand why those go there.
Let me see yours. Like, oh, you mean like the empty strings?
Yes.
Okay, so let's talk about that. Now, let's say you are, hold on, I'm trying to pull my code over here. So let me share mine. So, I'm not sharing. Ain't nobody told me nothing. Okay. All right. So
I snipped my screen down with a quickness.
So let's say that you are doing it like this and you don't want spaces between your data, your output. This does not contain spaces. I said concat. This is my function. I open up my parentheses. I list in my columns all day long. Ain't no spaces. Let's say that I do want spaces between my columns. That's where that empty string come into play. I gotta put a comma the same way I would put a string, but I need to put a space. Literally, I need to make that string a space. Space. And now I execute it and it puts spaces between there. Let's say you want a space you need a space in your new column. That's when you would have to literally put an empty string. This is a string. You know how I always tell y'all to put the single quotes around the value to make it a string? This is a string, but ain't nothing in it. It's empty. It's a space. That's in the event that you need spaces between your data. If you don't want spaces, you don't have to put them in there at all. But let's say,
see that I put enrollment here in that space. I thought you had to put something in there, like something had to be there.
Oh, like this part right here, like the empty.
Yes, like something had to be typed there. It couldn't be left blank.
Well, that would mean that like it's just like, how can I explain it? So I think, can you share your screen? Can you share your screen?
I had to delete because I went through enrollment. I didn't even
go through the students table. Oh, okay.
Right.
So think about it like, let's say Okay, think about it like this. Let's say you have 2 columns or more that has data that is like first name, last name. Naturally, if I need a first name, last name, naturally I might need to put a space between there. But let's say you are concatenating 2 fields that don't require space, like ID numbers, or you want to take certain numbers from this column and the last name from this person, and you want to put them together, or you want to create some kind of unique identifier where their ID is like the first 4 digits of their birthday and the last 5 digits of their last name or something like that, and you want to merge them together, then you wouldn't have a space. So think about this spot right here is literally empty. Ain't nothing in there. And when I say when this is a string, just how we have our where, this column equals, and I have to put the value in there, like literally what the value is of that column. This is empty. It ain't nothing in there. So it's putting data in there technically. Like if I was to put 1, 2, 3, it's gonna put it in there. Amy, 1, 2, 3. It's gonna put whatever I want in there. It's gonna put whatever I want in there. But if I make it, you see how I put 1, 2, 3, 1, 2, 3 down there. Mm-hmm. But if I make it empty, it ain't got nothing to put in there. So essentially, you control what you put in there. Yep. Let me see yours, Asia. Did that explain? Did that kind of answer it?
I think it's me. I think I'm the problem. So it's like a placeholder.
Yes. It's a placeholder. You can put whatever in your string. Let me stop sharing so I can see yours. You can put whatever in your string that you want to. Okay. So you just need a comma. Treat that. Now execute. There you go. Treat that column. Treat that column as a comma. Okay, look at line 3. We got concat, first name, last name, enrollment, as student information. That student information is literally a column. It's going to show up in your output as a column. So you just got to treat it like a column. You got to put that comma before and you got to put that comma after. The same way you do with your regular select statement. In your select statement, every time you list something, you list a comma. If you, in your natural language, think about your natural language, always try to relate stuff back to what you already do. In English, we are taught that when we list a series of things, I want A, B, and C. I list a comma between every last one of them. Do the same thing.
Okay, now it makes sense.
Yep. Always, what has worked for me, especially somebody that's like, we're non-traditional. We don't have computer science. We weren't like math, that wasn't our background. So to me, what has always helped leverage my understanding is to take it and relate it to something that I naturally do. If I'm writing a paragraph and I'm listing multiple things out, treat your code the same way. I always relate it back. When I'm listing something out, I want this, and this. I'm gonna throw a comma every single time. Bam, bam, bam. You got to put a comma between every column. Any other questions, y'all? Okay. So that is string functions. String functions, like I said, it falls into that data cleansing, that text analysis. It's part of that data analysis, like pre-analysis. Before you analyze some data, your data has to be structured. It has to be cleaned. You got to make sure that it's quality data, that all the dependencies are there, that if this column depends on that column, it's here. That goes into that pre-analysis, pre-prepping that data before you do any of those things. Data cleansing. In short, data cleansing. That's what that is. It's a sector of data cleansing.
I have a question.
Okay.
Okay, so the way that I wrote it is I'm used to writing the form, the where conditional statements, all that stuff. That's why I made a second select statement.
Yeah.
So what I just did, if it says select, I can basically replace the original select statement or code with the new select statement, and I'll get the new column or list that I'm trying to create. Is that what I'm understanding?
Like how I did this, like you only have what you need. Yeah. Mm-hmm. Put up whatever you put in. It's the saying in data, junkie and junk out. Whatever you put in is what you're gonna get out. In your select statement, whatever I want in my output, that's what I gotta put it. That's what I gotta put in there. If I don't want it, I just, just comment it out and ain't gonna bring it.
Is that a good practice, or should I do it a different way?
Which way? Like this? Mm-hmm. This is cool. Also, the way you did it is cool. Let's say that you are doing some data investigation for yourself. That's totally fine. I do it all the time. If I need to see the full data set and also a subset of data or something like that, I do it literally all the time. So either way is acceptable. I come in out stuff all the time. I come in out. Okay, you remember last session when I was telling y'all about how easy it is to get overwhelmed. Like this session today, I'm gonna give y'all like multiple things to do where you got to pull it from multiple tables and have multiple conditions. And I was telling y'all how easy it is to get overwhelmed if you look at like the full picture first. The best way to do it is piece by piece. So the way that I write my code is literally like I have what I need and I start from small. I take out what I don't need. Then I execute that. Then I come and add a where condition and I execute that. Like I literally start and build. No matter how, and I've done stored procedures with 600 lines of code, 800 lines of code. Like 1,100 lines of code. Like they keep going. And it literally starts from like foundation. Okay, I don't need that. Let me get rid of this. Okay, I need that. Let me have it. Like it just back and forth, back and forth. So just small, take out what you want, comment it out, execute, which is testing. Then go and add your condition. Execute, which is testing. Then go and add that. Then test that. Like it just keep going. So it's totally fine. In other words. As long as you understand what you're doing. Because that's the gap. When you get on your technical assessment, they're going to give the use cases like I give y'all. And they're going to ask you, okay, so what did you do? And just be able to understand and walk through your code. So, yep. Any other questions? Okay. So that is string functions. That's when you get into that data cleansing, that pre-analysis, making everything consistent, part of data analysis, that prepping work. That prepping work. So the next session, or the next module for today, objective, is subqueries. So what are subqueries? Subqueries are essentially a query inside of a query. And it's not uncommon to where subqueries are also called nested queries too. People call them either way. I've seen them called either way, subquery or nested query. And what does that mean? It's literally a query inside of a query. And subqueries fall into that filtering. It falls into like that complex filtering part of data analysis. Now, we already talked about filtering where we said where this column equals this, where this column equals that. That's filtering all day long. Those are conditions. Subqueries also fall under that filtering as well, but it's more advanced. It's like a little step further. Now, subquery, like I said, it's a query inside of a query. two different queries. And the way that it computes is it depends on the output of your internal query to do your output of your second one. Now, remember, everything goes back to foundational. Select these columns from this table, where everything go back to that. Everything. Now, look at this portion of your code. What do you think that this part is saying? Can y'all? Yeah, y'all see my mouse. What do you think that part is saying?
The average salary from the employees table.
Yep. Here we pulling the average salary from the employees table all day long. That's all we doing. That's it. That's all. Now we're gonna come up here, and what do you think that this portion of your code is doing?
Pulling it from the employees table.
Yep. What's your condition?
The salary.
Yep. What about it?
Pulling the average salary of the employee.
Yeah, we putting the average salary for the employees table, but what are we doing here? Delissa, you on mute.
Yeah. I don't know.
You don't know?
Phone a friend.
Phone a friend.
I always mess this sign up. Is it greater than salary?
Yep. Greater than the average salary. And I messed it up too. I literally have to make. Yeah, I literally have to go like
this. This way, L.
What is it? It's the I do the alligator mouth. I'm real childish. So
yeah, but I'm doing it too. But look, the L. Is this less than?
Yes, if it's L, it's less than.
Oh, see, I never heard
the L is this way. I thought it was the other way.
Don't let me confuse you.
Me either.
Let me Google it.
I have to. This is. This is greater than. Where salary is greater than this one. Where salary is greater than the average salary from the employees table. So what question is this answering?
Salary is greater than average?
Yes. 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 Give me the employee ID, the employee name, and the salary from the employees table where my salary is greater than the average salary, period. Now, this is when we go into the extreme condition, advanced, I'm sorry, not extreme. Advanced conditions. Advanced, because we got where here. We know where all day long. Where salary is greater than the average salary. Now, if I want to add even more conditions here, and I want to say, and salary is over 100,000, and salary is this, and I'm just add that right on the bottom of here. That's our logical operators. And. We already got our one condition. Now we can come down here with our logical operators. And employee ID is whatever. And employee name is this. And salary is between this range. That's what those logical operators. So that's exactly what this is doing. It's pulling the employee ID, employee name, salary from the employees table where the salary is greater than the average salary. This is called a subquery. And this, like I said, it falls into the advanced filtering. It's like asking a question inside of another question because my output for this one depends on the output of that one. Any questions? And remember, it's going to compile this one first. And then it's going to come back and use this one to do this one. That is a subquery all day long. A query inside of a query. Now, no questions. Okay. Now let's go into our customer order DB. Our orders DB. Y'all is orders. Orders DB. Let's go within our orders DB. You should have 1, 2, 3, 4, 5. It's 5 tables in this database. Do the same thing. Open your columns up. Just look at your data. Do some data investigation. And I'm going to type y'all use case. I be doing a data investigation like I haven't seen this before. I be over here just looking. Okay. I'm going to say it out loud once I get it. Once I type it in here so y'all have it. Okay, let me read this. Payment of an ID, payment amount is greater than every amount of payment method. Okay. Now, this is going to require, we're in one table. We're not in multiple tables, we're only in one table. This is going to require you to create a subquery and to apply some logical operators. So I'm going to actually pull up the logical operator screen for y'all as well. But the use case is to provide me with the payment ID, order ID, the payment date, the amount, and the payment method, where the amount is greater than the average amount, and the payment method is a credit card, and the payment is in the month of October 2024. So start small. Your data investigation. Do your data investigation. See which table that houses this data. Select your top 1,000 rows and start building your query from small. Start with your subquery first. And then literally layer each of those conditions on top of it. I'm going to say this one last thing before I go on mute because I'm about to write my code too and I'll be talking. I'm going to say my one last thing about to go on mute. So I got where, whatever your column is, greater than. You can only have one where statement. After your where is and. This counts as a where. So start out small and build upon it. And I'm about to go on mute. And if you want to talk through it or you feel like you just spinning your wheels, ring not ring, because like who does it? Like say hey, and you can share your screen and we can all collaboratively walk through it together. So I'm going on mute, y'all. Payments where amount is greater than amount from okay. And payment method equals card. Payment method equals credit card. and payment date. I also just posted a hint in the chat. So bye. I'm out. Payment date between.
Yeah, I'm totally. I gotta be walked through this like a 2-year-old because I'm lost.
Okay, I'm gonna get him. I'm still working on it. All right, I'm gonna get him a few minutes, and then we can walk through it together to make sure you got it.
Yeah.
Between 24, 10, 30, 01, and 2024, 10, 31. Okay. Y'all good?
Almost finishing and about to try to run it.
Okay.
Let's see how it goes.
All right. Do you need me to share my screen with the logical operators on there?
Yes, please.
Okay. Because y'all remember, it is okay. It's okay to look at stuff. The goal is not, there we go. The goal is not memorization, it's application.
Between, okay, 10. Oh, it's 24. This is, what's the payment date? That's the only thing that's going.
If that's the only thing, comment it out, execute, and then make sure that your date format is formatted the same way that it is in the actual.
I'm talking out loud. I'm on mute. I didn't realize I was on mute. Sorry.
It's all good.
Okay, so question. Mm-hmm. So I'm doing the payment date, but I'm seeing on the table it has multiple like years.
Let me see. So yours.
I'm not sure what year I would use for the payment date for October. 2024. My bad.
Oh, okay.
You see what happens when you read?
You good. All right. If y'all still stuck, we can just walk through it. To make sure you can ask any questions if you have any.
Yeah, I think I'm missing something.
Let me see yours. Oh, let me stop sharing so I can see yours. I'm gonna put you on the big screen. Okay. So, okay. Oh, so girl, ain't nothing wrong with yours. First of all, get rid of your top 1,000 because that's gonna limit your there you go. Now, Remember with our aggregate functions, we got our function, which is the ABG, and then we put whatever column that we're applying the function to in parentheses. So put parentheses around amount. You could have kept the brackets, but just put the parentheses.
Oh,
okay. And execute. Okay, so it's saying, okay, so we got where. Oh, okay. So let's talk about it. Okay, I didn't see this. So you actually don't have your subquery in here at all. So we got select from 1 through 7, 100% correct. Where after your where statement, you need to put your subquery. Let me share my screen.
Okay.
But other than that, yours is correct. I didn't even catch that first time. I really looked at it. Where the column, the amount column is greater than, and then you put your another query. You literally gonna have two queries, a query inside of your query. So where amount, which is what you have, greater than, and then open up your parentheses, select. That's where you put your average. That's where you put your aggregate function from the payments table. Yours is missing like the subquery. Did that make more sense?
Yes.
Did it execute?
Yes.
Perfect.
How many am I supposed to have?
Can I see yours just to share everybody?
I suppose today.
Ain't nobody saying you. Thank you. Let me see. Yes. 1,000,000%. Select. You got your select statement, you got your columns. All of your columns, that was what was asked for. You did it. From the payments table, where the amount, that amount column is greater than the select average amount from the payments all day long. Then you get into those logical operators. Then you say, and the payment date between the date range and the payment method in credit card. Or you could have said equals credit card. Either way, it still works. And or equal the same.
I thought that. I was like, can I say equals? And I was like, nah.
Yep.
And then it wasn't working, so I had to keep figuring that out.
Yep. Now, looking at her code, does anybody have any questions regarding like anything? Because anything.
Not necessarily about her code, but about mine.
Okay. Can we see
yours?
I
never would have got there.
I'm sorry, what did you say?
Let's see yours.
Okay. Oh, goodness.
Cross the fingers for the internet. Good job, Asia.
Thank you.
Kind of hot and heavy today. But y'all.
Seriously?
Oh no, it's gone. Yeah,
she said internet.
I know I shouldn't have said nothing.
So she said it immediately.
And it's going back out. Please.
Oh, I shouldn't have said nothing. My bad. I ain't gonna say get it off. I ain't even gonna look at it.
Don't talk about my internet.
Yeah.
She's sensitive.
I ain't even I can't talk because I have Xfinity and mine will stop working in a minute. Like
me too. I had Xfinity and we had a tornado, literally.
Oh no.
Yeah.
Oh my God, we had one last night.
Yeah. I'm glad y'all all right.
I was asleep. I wouldn't have known.
To them now.
I wouldn't have known.
I've lived in Texas my whole life. I will never be used to a tornado ever.
I'm from Oklahoma, but I live in Pennsylvania and we get tornadoes.
Okay, it's still trying to connect. So I guess when I am able to reconnect,
yeah, we'll revisit.
Hop in.
Yeah. Any other questions, y'all? All right. So let's take a moment to identify the skills and the work that we have done. So we have done the subqueries, which require you to, first of all, do your data investigation, because I didn't tell you the table. I did tell you the database. They required you to do the data investigation. Also, it required you to create your subquery. In addition to your subquery, you had to include your logical operators as well to make sure that you met all of those conditions. Where this condition is met, where the payment, where they use the credit card, and where they paid, and where they were in the where they use a credit card and when the transaction was in October. You know, those are the type of business questions you ask. But I wanted to take a moment to like identify those technical skills that are required to do that. So, okay, share my screen. Okay, so we got our, okay, so now we are into case statement. I'm back. Okay. Oh, you say you back, Alexis?
Okay, I can try to share it now.
Okay.
If you don't mind.
Okay. Yeah, let's talk about it because yours might help somebody else's. Hold on, let me put you on the big screen.
Not the Summer Jam screen, please.
Girl. Okay, you need to close your parentheses at the end of line 7 because that subquery has to go in parentheses.
So at the end of the
right there
database?
No, right there.
Okay.
Now, remember it can only be one where. So you got where amount is greater than. Anything else after that is going to be and or, but and in this case.
Okay, did I put the parentheses in the correct place?
Yeah. Now execute.
Okay.
Remember a subquery, there you go. A subquery is a query inside of a query, but that query has to literally be in parentheses. That full query. See online, select average amount from the table. That's your query right there. Close it off. It's a sub. It's getting it out of there. And because you already got your where, so you only have one where. You can't say where amount is greater than where payment amount is credit card. Where you can only say where, and then everything else got to be and.
Got it. Thank you.
You're welcome. You're very welcome. My thing stuck. Okay. Now, let me share my screen. Just remember subquery. A query, it's a whole full query inside of a query. That query, you gotta have your parentheses. Same way, I think Asia has a similar problem. It has to go in the parentheses. Now, let's get into case statements. So case statements, what are case statements? Case statements essentially fall into the if, then, else logic. It's applicable to analysis. Python uses it. A lot of other analytical tools uses it as well. Essentially, if this condition is met, then we're going to call it this. And it allows you to essentially create conditions that return values based on those conditions. For example, if you are within healthcare or if you are within education, if you are within a certain sector, to where when you always get this certain set of data or this certain ranking or this certain labeling or this certain number, it essentially means this. This is where you will use a case statement. It allows you to categorize your data based on certain conditions. Also, it allows your data set to just be really clean because you're going to actually create a new column based on those conditions. And I'm finna choke, so hold on. Okay. So it allows you to categorize your data based on those certain conditions. It essentially means, okay, well, if the data shows up like this, then we're going to call it this. It's a decision-making process based on if, then, else. Any questions before we get into like the code part of it? The syntax, rather. Now, this is your code. We are here. We selecting. This is what we do. Selecting this column, this column. Have our comma here because like we was talking about with Asia earlier, every time you listen out multiple columns, you have to put commas between it. So we have our comma here. Case. This case literally starts your case statement. Case. Case when this column score is greater than or equal to 90, then call it an A. When score is greater than or equal to 80, then call it a B. When this column is greater than or equal to 70, then call it a C. Anything else is the F. End as grade. Essentially, name this column grade from this table. Now, whatever your logical operators, whatever your conditions, they can still go right under this. I can say where student name is John, where the score is between 90 to 100. I can still put all of my logical operators and conditions right underneath this from statement. This is your case statement. The case statement is that if, then, else function or setup. And it essentially falls into the core part of your categories within analysis, like conditions. It just returns different values based on those conditions. That's all it does. Super useful. I used it a lot. And I actually, this and join statements and window functions, I actually kind of was like, I used to try to like, I was a whole senior data analyst and was still like scared of this. And I don't even know why, because it like makes perfect sense to me in my head now, but it didn't at the time. But it's essentially an if, then, else format. Also, it's just applicable in other parts of analysis as well. Like I said, Python uses something similar, which also goes back to like once you start understanding like code and stuff, you're gonna be able to like look at other coding languages and have some sort of idea on what it's doing. Like I wrote a script in PowerShell probably about 6 months ago and had never seen PowerShell a day in my life. And it's just because you know how like things work and you able to like see it. But it's essentially that if, then, else concept. Any questions? Oh, excuse me, sorry. Okay. Now, thank you, Delencia. Let's go into our healthcare system database. We're actually still just in one table. And yeah, all right. So let's go into our healthcare system database and I'm gonna write the use case in here. Do we have any questions while I type this out?
You want us to write this case statement?
Not now, because I'm giving you the use case. But yeah, you will have to apply a case statement. Yes, ma'am. Yes, ma'am. Yes, ma'am. We're going to talk through it. What you shaking your hair for? I see your hair. I see your hair. What you shaking your hair for?
I'm just, like you said, overwhelmed with information. So I got to take it piece by piece. So my initial reaction is usually shaking my head in disbelief. But I'm going to get in there and I'm going to do it.
We're going to walk through it. We're going to walk through it. Take it piece by piece, because I ain't even going to give y'all no logical operators on here. Just literally start from piece by piece. So provide me a list of all the patient IDs, test names, test date, and the result. If the result is severe issue, then label a patient as high risk. If the result is abnormal, then label the patient as medium risk. If the result is mild, then label the patient as low risk. Yeah, mild, right. If normal, then no risk. Name the column risk assessment. So start from your data investigation. Which tables has this actual data? Start from there first. Then once you do that by expanding your table, just looking at your columns. Okay, which tables has this? Then once you find it, select your top 1,000 rows and start building out your syntax piece by piece. And I'm going to write it with y'all because I'm going on mute. No risk. Normal. And if you get caught up on something, I have a question like why you writing, you don't have to wait till you get to the very end to like ask it. We can walk through it together.
Oh, bless you for saying that.
You girl, I know you didn't think that. Okay. I know you didn't think I was like you don't have to. We can literally whatever if you write something like what should I or whatever, just talk. We can talk through it, and that way you won't keep going on and on and on like carry something. It could be like wrong, and you like applying it wrong.
Okay. Was somebody else trying to say something when I said something? No.
No.
Okay. I thought I heard somebody else. I wanted to give them the chance to speak. Okay. So I'm getting an error for my case syntax.
Okay.
And I'm not. Don't talk about it. Don't talk about it. Don't talk about it.
I know you were still in the process of cleaning it up. So
yep.
Let me see. Okay.
But so when
Okay. Let's talk about these now. Okay. So remember anything so your case statement literally has to go in your select statement. It can't go after your table.
That's what I thought. Okay.
Now think about it from logically. If I'm retrieving data, think about it in our natural like things that we do. If I'm retrieving something, I gotta get it from somewhere. So that from like all your data that you're retrieving has to go before your from statement because I'm getting it from somewhere.
Okay.
So take your case statement and literally put it in your select statement.
Now, I guess this is where I start getting kind of lost a little bit.
Okay.
Do I need to list the different columns? Those are columns, right? Do I need to keep the different columns listed? Okay.
Yep. Because I need the patient ID, test name, test date, and result. I need all of that. There you go. Now, same conversation that we had with Asia in the very first beginning. Yep, your comma. Okay. Your comma, yep. Okay. There you go. Now we get into your case statement. So you're saying when result equals, that severe issue is a string because that's the actual data inside of the comma. There you go. And there you go. Now, why is result showing up like that? Hold on, let me see your result. Okay, your result is fine. I don't know why it's showing up red, so just keep writing it. But that's correct. When this column equals this, then that. When result equals abnormal, then medium risk. When result equals, and you keep going, categorizing your data all the way through like that.
Risk.
I'm gonna share the code so you can see it.
Okay.
Then anybody else? Oh, you got yours, Asia? Finally got my
defense, but I got it.
Finally got mine to work. Oh my God. Alexa, stop sharing your screen so they can see mine big.
Sorry.
Don't apologize, Alexis. Please don't. Please, ma'am. But case when that column equals that string, then we're gonna call it this. I know that's that, but we're gonna call it this. That's literally all that is doing. It really be the parentheses and that. Yes. It's always something silly. Like it's always something silly. But I think the fact that when it is something like a parentheses or a comma or something like that, it's like you know what you're doing. That's a simple like oversight. It must be. Not. And you see, you sitting over there acting a fool the whole time. You want us to do that? Yes, ma'am. Actually, yes. Actually, I do.
I'm working on it. But one thing about me is I'm gonna complain first. I'm gonna do it.
But you gonna do it.
But because I'm complaining.
That's fine.
I'm probably gonna cry.
I'll be crying.
Upset, but I'm gonna do it.
I be crying. I cry too. But I'm gonna do it though. I'm gonna boss up though. But let me cry first. Good job, y'all. Anybody else that was scared at first, but like, girl. Did anybody have any questions? Okay. Now, can you bring me back the code that I only want people that took a cholesterol test. So how would you format that? Good. Oh, that's Alexis. Okay, good. So any questions? I'm about to share my code. Delancey, are you good? Okay. So mine is similar to how Alexis was. We got our select, all our columns. Then we get into our case. Case when this column equals this severe issue, then high risk. When result equals abnormal, then medium risk. When result equals mild issue, then low risk. You just keep going. Else, let's call it not reported. And as risk assessment. We ended it right here as risk assessment. Then I said, well, I only want where they took a cholesterol test. So I just add my where filter, where test name equals cholesterol test. Because you essentially can just filter right on top of like or underneath whatever you've already done. Any questions? Who's that, Natalie? Or who's that? Oh, that's Asia. What happened?
I don't know. I think.
Let me see. Just share your screen.
Because I was trying to do the after cholesterol test.
Just do your where. Get rid of that line 16. I mean, no. Take your where and put it after your from. That's the problem. So whenever we're filtering data, it has to go after from. Think about, there you go. Think about naturally. If you go to the store, I be using the store for the examples because like everybody be going to the store. You go to the store and I tell you, can you go and you get this produce? You're getting it from that table. So that's the from. But whenever I filter it, I have to have the data first. Or let's say this is a better example. Let's say you're going to the store and I tell you, hey, Asia, can you bring me back a whole basket of milk? And you just go randomly picking up a whole basket of milk. You take your milk from the refrigerator, from the table, and you put it in your basket. You bring the basket to me, and I say, I want almond milk. So you got to pull it out of the basket, almond milk. I want half a gallon. You pull out the ballot, half a gallon. You got to have the data first, and then you filter it. You can't filter it if you don't have it first. So I always remember it logically like that. I'm selecting my data, and then I'm filtering it. You filter it first. You get your data, and then you filter from that data set. So always select from where. Always. Select from where. Always. It will never not be that. Ever. Any other questions? Okay. So I am not sharing. So let me move this out the way. All right. So let's get into the big thing, what we doing. So let's get into joins. So it is not uncommon for you to, when you are to retrieve data, that you have to retrieve data from multiple tables. And that will require you to join those tables together. One common question that people ask, like within technical assessments, are what are the types of joins? So have this somewhere handy. Joins are essentially taking multiple tables and joining them together to get data sets. Now, when you join tables together, you have to join those tables on common fields or common columns. That's why I really push y'all to do data investigation and to look at your data and to see what the relationships are, because that helps you when you get into having to join multiple tables, because you're going to join it on that common field. Power BI does the exact same thing. Power BI does their it's called, what is it called? It's called merge. And in Power BI, you got to merge them on the exact same column. They do the exact same thing. And it shows up literally at all parts of analysis. So with that being said, let's get into joins. Like I said, it is not uncommon when you get a data request that your data will be in multiple databases, which is why, like, I teach y'all like this. Okay, it's over here. Okay, it's over there. Because that's real. That's real life. Also, within multiple tables, it is very rare that you get a data request and it's like all the data housed in one table. So you have to join your tables. Now, there are 4 different types of joins: left join, inner join, right join, and a full outer join. And like I said, a super common question that people like to ask when you are in technical assessments is, so can you tell me about the different types of joins and what they do? They love it because it's the way to kind of weed out, like, at a very high level, if like people really kind of know them stuff. So there's 4 different types of joins. The inner join. Let's talk about the inner join. Inner join only returns back data if there is a match. That means that data has to exist in both of those tables to be returned back. Now, in that inner join, there is a risk that you potentially eliminate data, because if that data does not exist in both of those tables, it is not going to return back. It has to be common in both of those tables. And the way that I always describe that is, if that data is not common in both of those tables, it is not coming in your output. It is not going to exist. It ain't going to be there. Left join. Your left join returns all the data from your left table and common data from your right table. We're actually going to talk about left and right as well, because the left and right used to have me like, I didn't get it. Because, like, what you been talking about? And if I was on a technical assessment and I had to do a join, I would just be like sweating under my arms and like, I'll leave. Because, like, why am I here? So I explained it to y'all in a way that, like, I understand. That left join returns all the data from the left table, common data from the right table. And like I said, we'll talk about left and right on our next slide. Right join. All the data from the right table, common data from your left table. Full outer join returns all the data from all the tables, because you can have more than one or more than 2, all the data from all the tables, whether it's a match or not. It literally does not care. You will very rarely use a full outer join. Your go-to is going to be your inner join and your left join. Why? Because joins are typically used most of the time when people are trying to find matches between data sets. So they say, well, let's just join the table. The inner join gonna return you back matching data all day long. Left join, like I said, is the second most common. And the reason being is because naturally, the way that we're taught to write is left to right. When we write things like in a paragraph form, we're writing left to right. So naturally, the way that our brain kind of works is, if I need all of the data from a specific table, I'm just going to list that data, list that table first, which constitutes a left join. Please know this, y'all, because this is like, this the question that people ask in technical assessments when they don't really feel like doing them, but they trying to see if you know. Please have it somewhere. And when I used to do it, I literally like do my hands like a Venn diagram, because that's how my brain understands it. People love that question. Love it, love it, love it. Any questions before we go to the next? Get into our syntax. Okay. Inner joins. So remember, inner joins only return back common data. When I say common data, I mean that data has to exist in both of those tables. Now, This is our employees table. This is our departments table. When you do your data investigation, just like in a database, what's the common field between both of these tables? This is our employees table. This is our departments table. What's the common field? What relationship? I mean, what's the what field?
Department ID.
Yep.
Department ID.
Yep.
Yeah, department ID.
Yep. No different than when you're in the database and you are going through your database, you're looking at your columns. You're like, okay, well, they both have this column. Okay, well, they both have that column. It's literally the same thing. Now, let's get into our syntax for our join statement. Select. We selecting. That's all. We gonna select all day long. Select E dot name. What is this E dot? Like, what is this? What is it even talking about? Why is it here? Like, what is it? No.
Employees.
Yep. Yep. We have our employees table here. Here we put an E. We essentially are naming that employees table E. So in the event that you need to come and pull columns from that table, you can specify which table you're pulling that column from. Let's say I joined 3 tables and all 3 of those tables had the exact same column name. This allows me to specify which column though. I mean, which table though. This is the alias. You remember aliases from case statement and our aggregate function. I say you got to name stuff. It's the same concept. E dot name. So I'm pulling the name from the employees table, comma, D dot department name. I'm pulling the department name from the departments table. Select. These are my columns from this employees table. Inner join. I specify which join. Inner join. Department. On E dot department ID equals D dot department ID. I'm joining it on the department ID from my employees table and the department ID from my departments table. That is all it's doing. Think about like when you have a like Lego and you got your Legos and like they're built to like stack on top of each other. That's their own statement. They got to match. And when they match, they fit perfectly.